Okay, we are now looking at adjusting concentration using allegation medial, and this will be one of two lectures in this series of um, adjusting concentration and dilution. So, the outline of this lecture is that at the end of the lecture, participants should be able to calculate amounts of diluent and or active ingredients needed to prepare preparation of requested concentration using the concepts of allegation medial with 100% accuracy and without assistance. So we are hoping that is what we are going to achieve today. You will learn to dilute mixtures using the following methods of calculations: allegation medial and allegation alternate. I'm so sorry, the allegation should be spelled with an E and not with an I and not an E. We already looked at ratio and proportion and CSVS methods. So we're looking at allegation medial and allegation alternate now. In particular, for this part of the lecture, allegation medial. What is allegation medial? It is a method, it's an arithmetic method used in which the weighted average percentage strength of a mixture of two or more substances of known quantities and concentration may be easily calculated. So I'm going to show you an example. The example says, what is the percentage strength, volume in volume, of alcohol in a mixture of 3,000 mils of 40% volume in volume alcohol, 1,000 mils of 60% volume in volume alcohol, and 1,000 mils of 70% volume in volume alcohol. Let me paint the scenario for you. You're working in a hospital, or you're working in a manufacturing setting, or even just an institutionalized medical facility like a nursing home, and you are preparing a particular preparation using different mixtures of varying concentrations and amounts. You're going to mix those mixtures together to form one big product, and you need to know, determine what that final concentration is going to be. So here, for allegation medial, you do not know what the final concentration is going to be, neither do you know the final volume. It's really just a method to determine, if I mix all of these mixtures of varying concentration and amounts together, what would be my resulting volume and my resulting concentration of that mixture. Okay? So the first thing that you are going to ascertain here, we have 1, 2, 3 different mixtures of varying concentrations of alcohol, and you're going to mix them together. So that means you're going to mix the 3,000 mils of the 40% alcohol with the 1,000 mils 60% alcohol with the 1,000 mils 70% alcohol. And this is going to produce a volume of 5,000 mils. We know that because we add these volumes together. But what is the percentage strength? That is what we're going to have to determine. So the first thing we have to do is to express the percentage strength of each solution as a decimal. So we have the 3,000 mils of 40% alcohol. It's 40%, meaning 40 out of 100. That expressed as a decimal is 0.4, 0.6 for the 60%, and 0.7 for the 70%. So we have to determine what the decimal would be for the different concentrations. The next step is to determine the amount of alcohol that's contained in each solution by multiplying the decimal that you had determined in the previous step by the corresponding quantity. So 0.4 was the 40% alcohol. We multiply that by 3,000 mils, that's the quantity, and we get 1,200 mils. Same for the 60% alcohol, same for the 70% alcohol. So here just saying that I have 1,200 mils in my 3,000 mil solution of alcohol, pure alcohol. Good. And in my 60% 1000 ml solution, I have a total of 600 mils of pure alcohol. Similarly, for my 1000 ml 70% alcohol, I have 700 mils of pure alcohol to make that's in that solution. Alternatively, you could work it out the long way. You say, for example, you are calculating the amount of alcohol in the 40% 3000 ml solution. You use the concept of percentage strength or percentage concentration, which is the amount in every 100 parts, right? So if you have a 40% alcohol solution, it means that 40 mils of pure alcohol is going to be contained in every 100 mil of that solution. You have 3000 mils of that solution, so you can easily determine what the volume of alcohol would be in the 3000 mils, and that would have been 1200 mils. So that's basically what that is saying, but this is just an easier way of doing it. Right? So you can do it either way. So here we find that 1200 mils of alcohol is in the 3000 mils, 600 would be in 1000 mils, and 700 would be in the 1000 mils. When we add this together, we get 2500 mils. So 2500 mils would now be in, yes, 2500 mils will now be in the entire mixture of 5000 mils. So we now need to determine what the percentage concentration of the alcohol would be. And that would be, if 2500 mil of alcohol is contained in 5000 mils of mixture, then every 100 mil, which is percentage strength, would contain 50 mils, which is 50% volume in volume. Please ignore this example. This is not the example that we are doing presently, but the working out here is correct. So you determine that 2500 mils in total would be the total amount of alcohol that would have been in your final mixture had you mixed these three ingredients together. And when you put that 2500 over the 5000 times 100, you get 50, which is indicative of the concentration of alcohol in your final mixture, which is 50% volume in volume. What if you're saying you don't get it? That's fine. Let's do another example. If the following solutions were mixed, that is 200 mils of 40% volume in volume alcohol, 500 ml of 95% volume alcohol, and 1000 ml of a non-alcoholic solution, what would be the final percentage of the concentration of alcohol in your mixture? Now, again, we have to identify that we are mixing all of these liquids together. So we're going to get a final volume of 1700 mils. But we need now to determine, when you mix all of these ingredients together, what would be the final mixture of this 1700 mils in terms of alcohol. We know that this contains 40% alcohol, so we can easily determine the amount of alcohol that's in this 200 mils. We know 95% of this 500 ml will be pure alcohol, so we can determine what that is. But we have this. If you go back to the example, it says 1000 ml of non-alcoholic solution. What does that mean? If it's non-alcoholic solution, it means it has no alcohol in it. So therefore, you will not have any contribution of alcohol from this mixture. However, you're going to have contribution in terms of volume because you're mixing these three mixtures together. So let's see how we'll do that. First, we have to express the percentage strength of each component as a decimal. So for the 200 ml, 40%, 0.4, the 1000 ml, 95%, 0.95, and the 0%, and the non-alcoholic 1000 ml solution, of course, is going to be 0 because no alcohol is in it. So The next step is to determine the amount of alcohol that's contained in each mixture by multiplying the decimal by its corresponding quantity. 0.4 times 200 is going to give you 80 mils. 0.95 times the 500 is going to give you 475 mils. And 0 times 1,000 is going to give you 0 because there's no alcohol in it. When you add the 84 and the 475, you get a total of 555 mils of alcohol. Remember, there's an alternative way. If we don't like this way, we can do it old school way, the OG way, right? So let's say we're going to be calculating the amount of alcohol in the 95% 500 ml solution. We will say, okay, 95%, so 95 mils of pure alcohol is contained in 100 ml. Therefore, how much will be 500 mils? And we get 475. See, it's the same 475 we're going to get. So you'd have to do this though for each of the ingredients. Well, of course, with the exception of the non-alcoholic solution, because you already know that there's no alcohol in there. Once you have done that, then you add the values and you will get the total amount of alcohol that will be contributed by these two mixtures. So the next step now is to determine the total alcohol that will be in the final mixture after you mix those three ingredients together. So the total alcohol for the total mixture would be the 80 plus the 475 plus the 0 mils will give you 555 mils. Determine the final percentage of the alcohol in the final mixture. You'll have to know what the final volume of the mixture will be after you add the 200 ml, the 500 ml, and the 1000 mils. You get 1700 mils. Total alcohol that will be present in the 1700 mils will be 555. And then you determine how much will be each 100 mils, which is the percentage strength, which is 32.6 mils. So the percentage concentration is going to be 32.6% volume in volume. All right, so there are many other examples in your text. And don't worry, I'm going to be giving you exercises for you to do, and you should be able to attempt them and do them very well, because allegation medial is the easiest adjusting concentration concept in the entire dilution lesson. So this should not be a problem to you. So let's summarize. Allegation medial, you will see it mostly being applied to liquids, but it can be used for anything. It can be used for semi-solids such as creams and ointments. The concept is applied when different mixtures of different concentration of known amounts are mixed to create one product. And while the concentration of each mixture is known, the concentration of the final product must be determined. So remember those three mixtures that we mixed together, the non-alcoholic one and the other two alcohols, and we mixed them and we got 1700 mils. We know we get 1700 mils, but we won't know what the concentration is. We'll have to determine it. Okay, so we have come to the end of this part of the lesson, and I know that you would have gotten all the concepts and you're going to be able to apply them. Okay, so I will continue with allegation alternate on the other side of this lesson. Thank you so much for joining.